it's assigning names. Here you can say nomenclature of organic compound, which means we are naming organic compound. In early stages of development of organic chemistry, there was no systemic nomenclature. So we were using or we were naming a compound based upon the source from which it is originated. Say for example, formic acid. Formica represents red ants. That means this is an acid which is originated from red ants. That's the reason why they have named it as formic acid. Or take an example of oxalic acid. This is an acid which is obtained from oxalis plant. So it is named as oxalic acid. That means all these are the trivial names. So the system which we are following earlier was the trivial system. With the advancement of technology, there are a lot of organic compounds that are synthesized every year. So using trivial system of nomenclature creates a lot of confusion between the compounds. That's where Iupac has stepped in. Nothing but International Union of Pure and Applied Chemistry. They have set up certain rules for naming an organic compound. Stay tuned to this video in order to understand how to name an organic compound with the help of these rules. Welcome back, students. Let's understand how to name an organic compound. So here we'll study the general rules for Iupac nomenclature. Okay, so how to name an organic compound? You should know certain rules. Before that, any organic compound, that means the name of an organic compound consists of word root, prefix and suffix. So if you see an example like 2-methyl propane 1-ol, this is a name of an organic compound. Here you can see that prop represents word root and methyl represents prefix, 2 represents the position of prefix. Again, in suffix there are two types of suffix, primary suffix and secondary suffix. So here an represents primary suffix and ol, that is all, represents secondary suffix. So we'll understand all these rules, that means how to name a word root, how to name a prefix or suffix in this session. Okay, let's start with word root first. What is this word root all about? Word root is nothing but to determine the number of carbon atoms that is present in the parent chain. Now the question arises, what is parent chain? Parent chain is nothing but the longest continuous chain in that particular organic compound. So how many number of carbon atoms that are present in the longest continuous chain, that is your word root, remember. Okay, so this longest chain consists of multiple bonds, either double bond, triple bond or single bond. Also this longest chain consists of functional groups. So you have to select such a longest chain which consists of a functional group or multiple bonds. Now we'll see in detail about this word root here. Okay, so word root for different aliphatic compounds starts with alk. What is this alk? Alk is nothing but, here you can see different types of alks. For example, if the longest chain consists of only one carbon, then your word root is nothing but meth. So this meth stands for your alk. Alk is nothing but alkanes or alkanes, whatever it can be. So if you see 2 carbons eth, 3 carbons prop, 4 carbons but and so on, you can see how we name a word root. This depends upon the number of carbons that are present in the longest continuous chain. This is very, very important to name a word root. Moving on to suffix. What do you mean by suffix? Suffix is the one which comes after the word root. Okay, so this suffix can include functional groups or it can include multiple bonds, as I told you before. Now here you can see there are two types of suffix. One is your primary suffix and second is your secondary suffix. So primary suffix is the one where your multiple bonds are involved, whereas in the secondary suffix your functional groups are involved. So that is the difference between a primary suffix and secondary suffix. For example, assume that you have an organic compound which does not contain any functional group. Then that organic compound name consists of only primary suffix. But if you have a functional group, then it consists of both primary suffix and secondary suffix. Now, we'll study about the primary suffix here. So, as I told you, primary suffix consists of either double bond, triple bond or single bond, which is nothing but saturated or unsaturated. So, a basic primary suffix consists of like this. You can see saturated, that is carbon single bond carbon. Unsaturated can be either carbon double bond carbon or carbon triple bond carbon. Okay, what is suffix here? If you have only single bonds in your entire organic compound, then the suffix will always be "ane", right? If it consists of double bonds, it is "ene". If it consists of triple bond, it is "ine". So, single bond is "ane", double bond is "ene" and triple bond is "ine". So, that's where if you see the general name, alkanes, alkenes and alkynes. So, remember whatever I told you so far, this is all about your primary suffix. So, let's see about this primary suffix. So, numerical prefixes to primary suffixes. So, have a look at this nature of carbon chain, numerical prefix, primary suffix and general name. For example, if you have two double bonds, then the numerical prefix will be di. So, your primary prefix now it will be diene. So, it is called as alkadiene. If you have three double bonds, then it is triene. So, it is alkatriene. In the same way, if you have two triple bonds, it is called as diene, and three triple bonds, it is called as triene. So, if you see their general names, it will be alkadiene or alkatriene. Simple, right? So, your primary suffix can be number, right? Such as di or tri or tetra, and it should be followed by these numerical prefixes. Now, look at the secondary suffix. So, what do you mean by secondary suffix? Nothing but your functional groups. So, look at various functional groups here. So, what are these functional groups? All these comes under the category of secondary suffix. That means your name of an organic compound ends with this functional group. By looking at the secondary suffix, you should be able to say what is the functional group present in that particular compound. How do you do that? Very simple. Have a look at the class of organic compounds. All these lists corresponds to different functional groups, and you can see the functional group here. For example, alcohol OH, thioalcohol SH, aldehyde CHO, ketone CO, carboxylic acid CO, OH and so on. And the last column is the one which is very important for you to write an secondary suffix. For alcohols, it should be OL. If it is AL, then it is aldehyde. It's not alcohol. If it is thioalcohol, it is thiol. If it is carboxylic acid, it is oic acid. So, all these secondary suffix which you see in the last column is the one which you have to write down at the end of an organic compound. Is it clear? So, there is one more important point what you should know about these secondary suffix. What are those? It's like how do you write down the name? So, secondary suffix is added according to the following conventions. So, what are these conventions? The name of your secondary suffix can begin with either vowel or a consonant. Let's take the same example which we have seen earlier, 2-methyl propanemanol. Here, OL is your secondary suffix, right? So, O is an vowel, right? So, we are dropping E from the primary suffix. So, if you look at the name, in propane, there is no E over there because your O is an vowel. So, drop down the E. If it is a consonant, then E should be retained. So, these are very important points when you are writing suffix, especially secondary suffix. Now, let's have examples for various types of functional groups. Okay, here addition of secondary suffix to primary suffix happens like this. So, here what do you see? The name of the compound, word root, primary suffix, secondary suffix and finally the Iupac name. Let's have a look at the first example. So, here you have the word root as eth. Why? Because there are two carbons and your primary suffix is ane because there is no double bond or triple bond I can see there, and your secondary suffix is ol because the functional group is alcohol. So, the name is ethanol. So, can you see the E in the ethanol? No, right? Why? Because OL, that means O is an vowel. So, that's the reason why I have dropped down E. Whereas you look at the example of ethane nitrate, that is the fourth one in the row. So what is that? Methyl cyanide. Usually we call it as ethane nitrate, CH3CN. So here you can see there are two carbons, so it is eth, and there is nowhere you can see the presence of double bond or triple bond, so it is ane again. Now the functional group is here is nitrile, and it is called as ethane nitrile. Why? Because in secondary suffix N is a consonant, it is not an vowel. That's the reason why if you clearly see the IUPAC name, you can see that ethane, E is retained. Can you make out the difference between a vowel and a consonant? Look at the next example where you can see OH, CH2, CH2OH, that is ethane diol. So here also E is retained because in diol D is a consonant, it's not a vowel, so E is retained there, right? So that's where you have to understand how to write down the name with respect to vowel and a consonant. So we have seen what is word root, what is a primary suffix, and what is a secondary suffix. Now coming to prefixes. So prefixes are generally called as substituents. So you can say alkyl groups or any functional group that is other than the principal functional group. What do you mean by principal functional group? So for example, if you have an organic compound where there are presence of more than one functional group, so in that case only the functional group that is having more priority in the priority series, that is considered as a principal functional group. Rest all the functional groups are considered as a substituents only, right? So usually if you look at the priority table, carboxylic acid is the one which is having the highest priority. So for example, if you have a organic compound where you have a carboxylic acid and alcohol, here alcohol is considered as a substituent, whereas carboxylic acid is considered as a principal functional group. Let's see some of the examples for these prefixes. Usually, as I told you, alkyl groups. Some functional groups are named as substituents, as well as the functional groups in polyfunctional compounds are named as a substituents. Okay, let's have a look at these alkyl groups. Alkyl groups are nothing but where you have an alkanes, or that means hydrocarbons, and the hydrogen if you remove from that alkane will be your alkyl groups. So look at this, methane, remove one hydrogen, it comes to CH3. So this CH3 is your alkyl group. So generally these alkyl groups are derived from the hydrocarbons, especially the saturated hydrocarbons. So removing one hydrogen from that saturated hydrocarbons becomes your alkyl group. There are various alkyl groups you can say. So what are those alkyl groups? Let's have a look at here. So molecular formula and name of alkane. You can see the structural formula as well as the name of the alkyl group. Methane, remove one hydrogen, it is methyl. Ethane, remove one hydrogen, it becomes ethyl. So everywhere the molecular formula, I am removing one hydrogen from that respective alkane. That's where you end up with alkyl groups. So all these are nothing but your alkyl groups. They are present or they are attached to the carbon chains. So when you are selecting a longest carbon chain, you can see there are some groups which are left over. That means those groups which consist of carbon. Those are nothing but your alkyl groups. Clear? And these will be your prefixes. Now, moving on to the functional group named as substituents. Look at this. So what are these? Chloro, bromo, iodo, fluoro, NO, that is nitroso. You can say nitro, NO2. Alkoxy. So alkoxy is nothing but your ethers. NO2 is nitro compound, nitroso. So if you see last three, these are your functional groups, but always they are acting as your prefix only. They will never be your secondary suffixes, especially with nitro, nitroso and ethers, that is alkoxy group. And apart from that, you can see that chloro, bromo, fluoro, iodo. So all these always will be your prefixes. Also, we can see that these are the various functional groups. And in these functional groups, you can say that the highest priority group will be your principal functional group, and rest all the functional groups in that particular organic compound acts as a substituents. Clear? For example, if you say OH, OH as a secondary suffix, it ends with OL. But if this OH acts as a substituent or a prefix, then it becomes hydroxy, right? If it is NH2, it is amine. But if this NH2 acts as your substituent, that means prefix, then it is amino. Clear? CN, that is nitrile as a secondary suffix. But in the presence of other principal functional group, this acts as a cyano. So these are the list of the functional groups when they act as a substituents or prefixes. Clear? Now, complete IUPAC name of organic compound. So here you can say prefix plus word root plus primary suffix plus secondary suffix. All these comprises your IUPAC name, right? Okay, let's see one example here on how to write on the name. So here is your example. Now, what do? Firstly, I'll number the compound so that I am going to select the longest continuous chain. The longest continuous chain should consist of your functional group or a double bond or a triple bond. So here I am choosing the longest chain where there is presence of a functional group. So here it consists of 3 carbons. That's where the word root is proper. And here I can say the prefix is methyl. Because at second position I skipped 1 carbon, right? So that is your methyl, which is a substituent. And you can say your primary suffix is ane because I cannot see any double bond or triple bond in this compound. And my secondary suffix will be OL. So this OL is particularly present or attached to the first carbon. So I can say this is 1 OL. Now if you write on the complete name of this compound, this becomes the compound which we were discussing from the beginning, that is 2-methyl propane 1-ol. Got it? How do we name this compound? Can we look at another example here? Okay, look at this compound. This is cyclic in nature. What is the first rule? You have to number the compound. So I have chosen the first number to the carbon that is attached to OH because functional groups always should given the priority. Now, here the word root is hex, right? Because there are 6 carbons. And here the prefix is cyclo. This is one thing which you have to remember because this is a cyclic compound. If you don't write cyclo, then if I write on the name without indicating cyclo, then this indicates a linear chain. So cyclo represents this is a closed ring compound. So here the prefix is cyclomethyl because at third position there is attachment of methyl group. So that is your substituent. And primary suffix is ane because I cannot see any double bond or triple bond in it. And my secondary suffix is OL because at the first carbon there is presence of hydroxy group that is attached. Now the IUPAC name for this is going to be 3-methyl cyclohexane 1-ol. Again you can see here hexane, there is no E because O is your OL. Is that clear to you? So what we have seen so far? We have understood the general rules for IUPAC nomenclature. What is the general rules? So this any organic compound should consist of word root, you have prefix, primary suffix and then secondary suffix. So that's all about this video. Stay tuned to our next video to understand the nomenclature of alkanes. Thank you.